On the previous page, in previous discussions of Benford's law and fraudulent tax returns, we examined the probability distributions for the quantitative variable, first digit in reported income. Fraudulent tax returns had a higher average first digit and a much smaller standard deviation. In that example, you may have wondered how we found the mean and standard deviation of the probability distribution. We will now work on a few examples to demonstrate how to find the mean of a probability distribution. We will not require you to learn to calculate the standard deviation by hand. In general, we'll just use technology to do these calculations. But just in case you're curious, or just to show everything in this class, even if we might not use it necessarily, here's our formula. So, in other words, in this blue writing, you can see them saying, the mean equals the sum of the values of x multiplied by their probabilities. So the mean of the probability distribution is a weighted mean. Each value is weighted by its probability. Now let's look at an example of calculating the mean of a probability distribution for a quantitative variable. Students often change their major when they are in college. In this example, the variable is the number of times a student changes their major. Using thousands of student records, we use our data to create the following empirical probability distribution from relative frequencies. Let's say the top row represents the number of changes in their major. The bottom row represents the probability of that number being the number of times you change majors. So I think pretty much everybody changes their major, but we always assume that, oh, we must have messed up. I changed my major, but look at, if you change your major 0 times, you just stick with the same major, that you only have a 13.5% chance of that. Everybody else, the 86.5% of people, they have changed their majors at least once, so don't feel so bad if you have already done that, or you plan to. What's the average number of times a student will change their major? So that would be kind of hard to do if we're not really sure about probabilities. So this tells the number of times a student changes their major and the probability of it happening. It looks like it's going to center around 2 or 3. These are the highest probabilities here, 0.271 for both 1 change in major and 2 change in majors. So before we dive into the calculation, let's estimate the mean using the histogram of the probability distribution. So all we did was take these numbers, the probabilities, and mark them as bars on a histogram between 0.00 and 0.30, because all these probabilities are somewhere in there. The median will be somewhere between 1 and 2, like we said. Those had the highest probabilities. The right skew in this data, we only see that it's kind of right skewed. I guess in the table we could have seen it, but it's definitely more obvious in the graph. It suggests that the mean will be a little larger, maybe closer to 2. Now let's calculate the mean. We first calculate x multiplied by probability of x for each of the values of x to get the mean. They've really shown it here. I'm sorry, that was a big pause. I've really shown it here. So for each of these, the probability of the number of changes in major being 0 is, well, the probability was from the previous data table. I multiply these two numbers. The number of times I change my major by the number of times, or the probability of that, and I multiply them and I get the number below 0. And then same thing here. Now that I'm done with that, separate them. I'm going to multiply 1, which is the number of changes in major in this column, multiplied by its probability, 0.271, and I get 0.271. And I'll do the same for each of these. I multiply the number in the first row by the number in the second row in each particular column, and I get a new number. So the next step would be to add these all together. All those values from this bottom row here, they're all going together and adding to make a total. It's 2.002. Sorry, that's a lot of stuff going on here, but the mean number of times a student changes their major is 2.002. The mean of a probability distribution is also called the expected value. So that might be something that's worth writing down. I'd probably write that down as well, even though we're not going to calculate these means by hand for the most part. You should probably write that down. That's the number, if this is a quantitative variable, a value like a number like this, the number of times that we change a major, multiply that number by its probability, add all those together for all the different possibilities, and that'll be the mean. Why is the mean a weighted average? The variable values are not equally likely to occur. Therefore, it makes sense to count more heavily those values of x that have a high probability. By multiplying each variable value times its probability, the formula weights the more likely outcomes more heavily and the less likely outcomes less heavily. On the next page, we'll work another example.